Hey everybody, Scout Crafty here again, Mishmash Monday. Hope you had a great weekend. We got a few things to do today. I know I promised that today we'll be doing a review on if you're buying your first drill or whatnot, but there's a few more drills I wanted to add into the mix, and we're going to do that on Wednesday. And the reason is today I had so many good questions on last week's videos that I had to get around to answer some of them, and I think that it'll help everybody if I just answer some of these great questions that were asked last week. So let's get right to that now. Okay, our first question comes from Michael Bradley from Canada. Michael said he's experiencing some runout with his chuck. What can he do? And that's a common problem. Let's talk about it. Okay, so now what we have here is this is your standard chuck. It's found on most drills. It's called a geared chuck because it has gears over here that you're used to tighten and loosen the chuck. There are many different types of chucks. There's chucks on lathes. There's chucks everywhere. They all have a little bit of what we call runout. Runout is when you put something into the chuck, it's not going to spin perfectly true. There's always going to be a little wobble. It's called runout. Collets are what you use to get a much more true running, but because this is convenient, we use a chuck. Now, when you tighten up something, here we're using what's called a dowel pin. They're very straight, very accurate. That's a good thing to test for your runout. We're going to tighten up the chuck a little bit. It don't have to be super tight, but we're just going to snug it up, and we're going to put a dial indicator on here to check the runout. This particular drill press has very bad runout. Now, to check our runout, we're going to use what's called a dial indicator. This is the reason I'm using this one. This is the most common one that most people have. We have better ones for checking runout, but this one will work. And it has a magnetic base. You can see by turning this, it'll magnetize the base. And this is a dial indicator. Now, every one of those notches that you see there, every one of those is 1/1000th of an inch. So when you start with 0 here and you go, that's 10/1000ths of an inch, that's 20/1000ths of an inch. And you can see how little you move because a thousandth of an inch is, you know, we're talking super, super small. And there's a little dial that tells you how many. But we're going to check the runout of the drill by putting this on that dial. Okay, now here we have the dial indicator resting on the center of the dowel pin, meaning the center mass, so that it's not on one side or the other. Not that it matters too much, but when I turn this on, you're going to see this flicker, and then you can get the approximate variation. And I'm going to show you the wobble that we have with this particular drill press. Now we have about 15,000 run. That's a lot. And this, like I said, you can tell. Now if you look here at the very bottom, look at here. I'm going to try and focus in on that bottom there. Look there and watch how that wobbles when I turn it on. Now, that's crazy, right? You say, that's a lot of runout, and it will. It'll give you oblong holes, things like that, but you deal with that. And, you know, you don't have to be that accurate with 90% of the holes that you drill unless you're drilling with metal or something like that. Now, that particular chuck is just a bad situation here, but we have other drills, and we'll check some of the other runouts to show you what I mean. Now, here we'll check the runout of this, the drill stand that we just did, the portable drill. These were never meant to be super accurate. Let's check the runout on this here. Okay, there you see what, 10, 12,000ths of runout. Okay, let's check something else. Here we have a Harbor Freight inexpensive drill press with the keyless chuck on here. Let's check out what the runout is on this one here. You can see it's considerably less with the keyless chuck, and again, it all depends on what type of chuck you're running. We're all running the same pin on each one. This is a collet, and how a collet works, as you can see, it has just a round piece of metal that your bit fits in and squeezes down accurate. They are much more accurate. Let's take a readout with a collet. Using a collet in my milling machine, which is traditionally more accurate because it has to be, it's doing metal. Let's turn this on and see what we get here. Okay, here you see we have 1,000 runout. You see the difference and why you need it with metal and what the difference is? Last up, we mounted a very accurate drill chuck in my milling machine, and I'll show you what kind of runout we get. Okay, there we just have about 1,500. but you could see because of that's an accurate drill chuck in an accurate machine. To answer Michael's question, runout is always going to be there, but how much? It's sometimes you could cut it down by reseating the chuck, taking the chuck off, cleaning it, make sure there's no dirt or particles, putting it back on, turning it around, you know, turning it like 180 or 90 degrees when you're remounting it. So there's little tricks to try and get the runout out, but a lot of times it's the machine itself, it's the bearings, it's the way it's held in. The tolerances of the machine is always going to be accuracy. You're always going to be chasing your tail. You'll never get it super accurate, especially with an older machine. So I hope that helps. Okay, next up, Dennis asked, he said, how come the power cords are you have it so short on here? And the reason I did that, and I'm doing it on all my machines that I changed the cord, long cords are nothing but a problem. They're hard to store, they're hard to wrap, you know, they get wrapped around the machine like Dave, my buddy old Sneelock, said, and what happens is you start getting a break around here. Nothing but an issue with long cords. So have a short cord and an extension cord, and you could wrap the extension cord, bring it around with it, but it's separate. You know, a lot of the higher end drills like Milwaukee, things like that, they have a detachable cord that you can click off and take off and then store the tool. Long cords are nice when you work, but it's just as easy to carry an extension cord, plug it in. So that's the way I prefer it, and that's why I'm changing all my tools to short cords. Okay, next up, my buddy Tony had a great question. Tony said, you know, when you're grounding the plug and you're putting a grounded plug in one of these old drills, where do you ground it out to? Which is a great question. Actually, Tony, it's super simple. You just have to ground it anywhere you can on the case. All this case is connected. If it was only the front of the part of the drill that had metal, you would try and connect it to something that connected to the front. But what I did is I took a solderless connector with a round circle and I put it around the screw on the inside of here so that I have a good ground. Now, if you get one of these old drills and it's got a grounded plug, never assume that they did it correctly. Some people they think they're doing the right thing. They're putting the cord in here and they're cutting the ground off, and they think just because it's got a grounded plug, they're protected. It's not. This has to be connected to the case to work as a proper ground. And how you check that is a regular volt ohm meter. You put it on ohms, and this one here has a sound position. So when I touch it, you hear that sound? So now what I'm going to do is I'm going to touch the ground of the plug, and I'm going to touch the case. Now, when you touch the case, I should have an indication of a continuity. You see that? All over the drill, all the metal is connected. So that means I don't have to worry about getting shocked. So it's no rocket science. Just put that ground. My buddy Jim, not too fast for you to see, he couldn't find a spot. So on one of his drills, he put a rivet in one of these holes and just did it that way. But you have to have just the ground part going to any part of the case, and that's it. You're good to go. Okay, next up, our buddy Chuck had a good question. He says, listen, I'm wiring up a drill. I got 3 wires. What wire goes where? Which one do I cut? Which one? It's a great question, Chuck. And here's what, you know, most wires you're going to get replacement. And these are the ones I like to buy. I like to buy the 3-foot power cords for my drills because, like I said, there's not excessive wire hanging out. Now, if you're working around a bench and only a bench, you might want the 6-foot, or they even have a 9-foot, same thing. But these are good for 13 amps, and it's a great cord. So you can see that most of the cords you're going to get, the replacement cords, will have 3 wires. This is in the USA, of course. You'll have a black, which is the hot, a white, which is the neutral, and a green, which is the ground, okay? Now, whenever you're going into these drills here, when you open it up, you'll have 2 wires. One will go to the stator and one will go to the switch, okay? So the one that goes to the switch is the one that's going to cut the power, and that's always where you want to put the hot lead. The black one always goes to the switch, because the white one is where the power goes back to the box. It goes in through the hot, out through the white, and of course the green just protects you. Now, if you have any issues when you're taking this apart, like I said, always put the power line to the switch first, because that cuts off the juice right away. Next up, our buddy 357 Magdad had a fantastic question. He said, you know, I noticed, and a couple people obviously noticed this, that when I held the drill in my hand, they say, man, that's a kind of a short handle. And it was a short handle. A lot of these earlier designs, and they did it by the time the 70s rolled around with the double insulated drills, the handles were much longer. But they did have, at the same time, they did have longer handle models. They were different. They were usually a heavier duty case, but for some reason, a lot of the drills, mostly the fix-it, the homeowner type, or of a shorter handle. But again, with this little kickback up here, believe it or not, I think a lot of these drills, a lot of people used to hold like this. You know, they would kind of put their finger along here and operate this with their middle finger. Believe it or not, because, and again, you grip it here in the front. So this seems to be a way a lot of people would have operated it. You know, that you kind of get that ergonomic feel like that. And I know I did on many early jobs that I was doing when I was working with these drills. And they kept that little kickback here. And again, these were meant to work into the, remember the drill press stands. This one here is a beautiful Black & Decker hole gun. This was like their top of the line drill. But again, look at the short handle. If I tried to go, my pinky's hanging off there, you know. So unless I move my hand up a little bit, put my finger here, and, you know, again, worked it with my middle finger. So I don't know what the thought was behind it. Here's another one. This is their special, you know, the 1/4-inch special drill. But this one had a slightly longer. But again, the same thing. You can't get your whole hand on there. Whereas the later model jobs, you could. They had a longer handle. And it's funny because their commercial drills had a much longer handle, oversized, because of the added torque of those higher torque drills. Okay, last up, Unwired asked a good question, which a couple people also asked. They said, how much grease? And, you know, you didn't show the grease and adding the grease. And you know something, that's a good question. I'll tell you the truth, if you ask 5 people, you might get 5 different answers. I'm going to give you my take on how to grease and how much grease you should put in to this drill. So let's take this apart and show you. Okay, now here we have the gear housing apart. Now I'm from the school of thought that says, you know, you don't want to put it on too sparingly with like an acid brush, and you don't want to glob it on with 3 fingers, just fill the whole pocket in there with grease. This is how much grease I put in there, and I'm very comfortable with that. And you can see everything is coated. Everything, all the gears are coated. The bearing has grease. You don't want too much grease on that bearing, but you know, enough that it's not getting spewed around. That's how much I put in there. And it seems to, and again, I'm using a super high quality grease. I'm using Super Lube. It's a multi-purpose synthetic grease and this is very expensive. So 3 fingers of that will cost you quite a bit. So, I guess if I was using the real cheap stuff, I might use more, but that's fine. It works really good. It's very. So in closing, I think it's a little bit of common sense. I think obviously the light duty drill that we did last week, it's very light duty and it only has 1 gear in there. You can get by with very little grease. Whereas if you were dealing with multiple gears or a gear train and it's a heavy duty, a 1/2 inch or a 3/4 inch drive, and you're going to be putting a lot of torque on it, you're going to want more grease in there. So I think it's something like that, just common sense, and just use a good quality grease that's clean. That's all that really counts, as long as it's there. Anyway, I hope these questions helped out. And Wednesday we'll do the the differences between certain drills that you might want to consider purchasing. So I hope you enjoyed this one. I hope you have a great day. Take care now. Bye-bye. I always find it interesting, the power differences. This here is a 1.5 amps. This one is the one we did last time. You can hear it. It sounds a little bit on the weak side. Here is just about 2 amps. You can hear the difference in that. And then this one here, this is 2.7 amps, which is a lot at the time. You can see the differences.